our session today on predictive maintenance. This is the 5th webinar in the first series of the Made Smarter Innovation Network webinar series. My name is Nicole Ballantyne. I'm a knowledge transfer manager in the manufacturing team at KTN. First of all, who are KTN? So there we are. KTN exists to connect for positive change, and that can be business to business, academia, investor. We're experts in network innovation and have been Innovate UK's trusted partner for many years. I'm really excited to get to the speakers. However, I just want to give a bit of a background to set the scene of why we're doing this series. In 2016-17, Jürgen Meyer led a team of UK industrialists to create a vision for the acceleration of the use of digital technologies in manufacturing to improve productivity. From that review, there was 4 main recommendations: adoption, innovation, leadership and skills. The adoption activity, of course, we know we've all heard, I think, about the Northwest pilot, and now it's been rolled out into 3 other regions: the Northeast, Yorkshire and Humber and West Midlands. The leadership and skills part of the recommendations has been led by Ingenuity, and all the information on that can be found on their Engage platform. The innovation part, by far the biggest part, is led by the Industrial Strategy Challenge Fund team at Innovate UK, the programme being known as the Manufacturing Made Smarter Challenge. This ambitious innovation programme will, over the next 3 years, invest over £300 million in supporting manufacturers, digital technology developers, founders and academics to innovate solutions to support the increase in productivity in the manufacturing sector in the UK, and of course to export technology solutions to the global manufacturing community. A number of the interventions are underway already. For example, CR&D1, the Fast Starts programme, CR&D2 digital supply chains has just been contracted. There's a Made Smarter Digital Accelerator being led by the DigiCat, and there's a Innovation Hubs pilot that is being led both by HVM Capital and the University of Swansea. Further information on all these interventions is starting to appear in the madesmarter.uk website, the central portal for Industry 4 knowledge. The network activity, such as this webinar series, aims to promote the communication of the latest projects, the technologies, the developments, and develop a community of collaborators innovating to support productivity improvements in UK manufacturing, way past the remit of the Made Smarter programme. In the webinar series, we wanted to give you insights into the art of the possible, starting with the viewpoint always of the manufacturer. We know there's very few plug-and-play solutions for our incredibly diverse manufacturing sector in the UK, and there's always some integration and some innovation needed, and therefore some pain to be experienced before the results start to flow. And it's these stories we're wanting to air. There's so much awesome work going on around the UK, and the Made Smarter Innovation Network and the madesmarter.uk portal will be our way of sharing the stories and spreading the knowledge and success of this vibrant community. We'll keep you updated on the progress following this webinar, and we'll send you info on how you can stay in the loop. So where are we right now? Well, using KTN's extensive technology and sector knowledge, we've set up a programme that will support the Manufacturing Made Smarter Industrial Strategy Challenge, the innovation part of the Made Smarter programme. We have activity plans in all sectors and technology areas who are engaging with all known networks, and we're continually scouting for new technologies that can support the manufacturing sector. And we're keen to hear and share your stories of change. An example of what we do is convene such events as, the next slide, the RAI Showcase. So this is an activity that's happening, the Robotics and AI Showcase. And there's a link there, and we'll send further details after this webinar. Also, in our continual hunt for new technologies and startups and supporting UK IP and tech founders, of course, Innovation Alley, something that's been happening for the last 3 years, a Digital Manufacturing Week in Liverpool in November, hoping to be an in-person event this year. And again, if you know of or you are a new technology company and would like a place on Innovation Alley, then there is the link. Please, we're starting the expressions of interest quite early this year. Now, the super exciting bit, our speakers. So this webinar convenes speakers from across Europe looking at challenges of innovating predictive maintenance solutions. We start with two viewpoints on a specific collaborative story around predicting screw wear in an injection molding machine manufactured by Engel, utilising built-in sensor technology from the UK innovator Tribology. So there are our presenters, Paul, Christina, Giuseppe and Ray. And really, let's get on with it. So Paul, over to you if you'd like to tell your story from a machinery manufacturer perspective.
Yeah, sure. Thanks for the introduction, Nicole. So I'm going to share my screen. So I hope you can see it.
Yes.
Can you confirm? All right, perfect. So we make use of digital technology to improve availability and minimize maintenance costs at our customers' end. And the question is, of course, maintenance. My name is Paul Capella. I'm the head of product management for digital solutions at Engel. And together with Wayne Ball, the CSD business development manager of Engel UK, we are providing you with an exclusive insight into our path to prediction on one of our first development projects in condition monitoring. But first, let's quickly look into some information around Engel, as I assume not all of you know the company. So we are one of the leading plastics machinery manufacturers and offer injection molding solutions for any kind of application. So our customers produce parts like you can see them in the picture. So the variety and the range is endless, from toothbrushes to lighting systems of cars, packaging for beverages, toys, and so on. And we are a family-owned business worldwide that generate around 1.1 billion euros of turnover every year. And what I also think is interesting is that we investing 70 million euros a year in research and development. And this sum is split across our whole portfolio with, of course, our core competence being the injection molding machine itself. However, we're also providing solutions around automation, service, process, and plasticizing technology, and especially, of course, also digital solutions, how we call it, Inject 4.0. And exactly within this topic, we have an initiative running that deals with predictive maintenance. And the question is, of course, how and why do we need maintenance?
Hi, Paul. We seem to be losing your sound, so it might help for you just to, if you turn your video, your camera off.
In today's injection molding maintenance, the strategy is preventive maintenance or react to. Yeah. So the question is, however, of course, where maintenance sits today. So what's the today's strategies of our customers or the possibilities that they have? So in maintenance today, when customers do preventive maintenance or react to issues, they often, these strategies often lead to unplanned downtimes, high preventive maintenance efforts to check the parts of the machines. Sometimes customers build up stock to use the spare parts when they are required, but sometimes they don't even are needed because the parts don't wear out. And of course, sometimes we have symptoms on the machines. We fight those symptoms, but it takes too much time to find out what's the root cause. So basically, by analyzing the condition of the machine or the condition of specific components in the machine, we can avoid these issues and challenges and overcome them. And actually, we are developing and providing specific monitoring services. So here you get an overview of the different modules that we developed. So basically each project is focusing on one component that we think is key for processing with our machines. So every project means a different specific development project for us. And of course, we want to understand how the wear occurs and match it then with additional or existing sensors, develop algorithms to provide insight to our customers. And the example that I'd like to show you today is focusing on the plasticizing screw. So why the screw? Well, to understand why we selected it, I'll quickly explain the injection molding process. So basically, polymer is fed into the injection unit, so on the right-hand side of the machine. A barrel is heated up, so the material is melted and then pushed into the mold, which shapes the polymer into the desired form. And this process is then repeated. For instance, could be every 10 seconds that you get, let's say, such a bucket out of the machine. And now the plasticizing screw that we want to monitor is sitting inside the barrel at the injection unit, and you can't access it from outside. So you can't look at the screw from the outside. And the plasticizing screw influences the product's quality because during the plasticizing, the grains are fed from the barrel, as I mentioned, and the friction on the surface of the barrel with the screw flights then basically leads to the melting process. So the grains start to melt. And in addition, we have cylinder heating with, let's say, several hundreds of degrees that are necessary for startup or balancing thermal losses. However, 2/3 of the energy to heat is produced by the friction. And of course, friction causes wear. And wear then influences our process, and by the process influence also the quality of the parts that come out. And our customers, they have a specific challenge there because you can't quickly check the screw. They usually have two different strategies. Either they do regular measurements, so say, okay, let's pull the screw once a year or once half a year, and by that, of course, check its condition. However, here, of course, you have perhaps unnecessary downtime when the screw's condition is okay. So most of the customers, or many, they measure based on process deviations. So when they already have issues with the product quality, but when at that time the screw is worn out, they need to wait for the spare part to come and have a downtime that's unplanned and can take several days. And only to check the screw alone, depending on the machine size, can take up to several days. So we thought, okay, we need to develop a solution to look inside the cylinder without disassembling the screw and the flange to check the screw wear. So we're using ultrasonic technology to measure or basically detect reflections when we look at send signals through the barrel to the screw and determine the wear of the screw flights. And right now, these measurements are done by our technicians. The data is then uploaded to our platform, gets analyzed, and customers then receive their result in a specific front end, a web portal that we call eConnect, so our customer portal. Where do we stand today? Well, we have our first customers in the UK. In this case, it's a company Polypipe. They manufacture piping, underfloor heating, and ventilation articles and solutions. And there we measured a screw, which has a specific geometry. It's called barrier screw with a diameter of 135 millimeters. So it's already at a larger end. So with our measurements, the result was there after an hour. However, when they would have pulled the screw and done the conventional maintenance strategy, it would have taken 2 shifts. So already here you have a lot of time saved to check the screw's condition. And down there you see the screenshot of how it looks like in the customer portal. So the customer there immediately sees the result. And of course, we also have validated the measurements, as you see on the right-hand side. The precision of the measurements is really good when you compare, perhaps like here, an ultrasonic gap of 0.16 millimeters with a manually measured gap of 0.15 millimeters, where there's nearly no difference. So when you measure manually, you also have some precision topics. So we can say the validation is pretty good and the precision is pretty high. How did we get there? So our top challenge was basically finding the right ultrasonic setup. So as we have these high temperatures, also the signal quality and stability was key. So in the beginning, in the first versions, we had to use cooling to basically cool the sensor, as there was no sensor on the market withstanding these high temperatures, which is of course quite inefficient. And also due to electronic interferences under real customer conditions, we had issues with the signal quality. So there was no setup on the market. We tested various ones that fulfilled our requirements off the shelf. And that's why we looked out for a company to develop this together with us. And so we ended up with Tribology, who will show their solutions in a few minutes. And we have a perfect solution for our customers today, and also for our employees, so they can mount the sensor quite easily and then do the measurements. We have a pretty good signal quality, and also put down the groundwork to do a permanent measuring, so we can predict the wear in the future. And on the right-hand side, you basically see how this looks like in the customer portal. Yeah, obviously all these technological innovations are not of any benefit if they can't make it to the customer. So Wayne, can you tell us more on how we promote this then in the UK?
Yep. Yeah, sure. Thanks, Paul. So my role in the UK is as after-sales business development manager. And my role is to constantly review the portfolio of products that we're offering the customers in our market. We have about 2,000 injection molding machines in the market in the UK and Ireland. And the portfolio of products is constantly growing. So we're looking after everything from interfaces for data capture, remote support, and of course, routine maintenance packages for the customer. Within our portfolio, we have a range of products called the care products. And traditionally, those products have been routine preventative maintenance products. So we go to the customer every year, we would sample the oil in the machine, we do various production checks, make sure the machine is level and aligned, and we do that once a year. What we've seen is that with screw wear measurement, now that it's a reality, of course, I've seen this product go from an idea to development to testing to real life production situations. And that's meant that we can now expand the care group of products to include something we're calling proactive, which means that as well as giving the machine an MOT every year, we can check on a predictive footing what is happening with the machine in terms of mean time to failure and the wear within the plasticizing unit in particular. We now have our pricing strategy set for what is care proactive to include the screw wear measurement, and we've just started to promote it on a local level for our customers. And so far the reaction is very good, because as Paul mentioned, the biggest benefit is actually that the customer can now see what's happening in terms of wear and plan for his replacement of components rather than experiencing unplanned downtime. And of course, that means that he can really budget in terms of costs and is not going to be hit with unbudgeted costs for machine failure. So,
Thank you so much, Wayne. And I think what I love about the Engel story is the fact, you said it went from innovation and all the development, a typical kind of innovation journey. But what you've now done is you made that, accessible.
It's the reality. It's a reality.
As a retrofit product. So let's now, Christina, if you would like to take the screen and tell us all about that innovation, please. Christina, are you there?
Yes, I am. I've just unmuted myself.
Take over.
I'm taking over. Hang on. Oh, I can't make the screen bigger. Hold on. There we go. Okay, give me a thumbs up if you can all hear me and see the screen. Great. Thank you very much. So thank you for the invitation today. I'm happy for people to connect and say hi on LinkedIn and Twitter. Really excited to be here as the tech provider and presenting alongside Engel, where, you know, we made this thing possible, but we made it possible together. Neither of us could have done this on our own. So I love Nicole's introduction and her post on LinkedIn. I thought you really summarized it. Fantastic. So we're a high-tech scale-up. We're based in Sheffield and we provide sensing solutions. We've collaborated with the leading injection molding manufacturing machine manufacturer, Engel, which is, you know, it's been a really exciting journey for us. And you'll see through my presentation where it's taken us from, you know, an original challenge that was there. So we developed a patented sensing solution to predict screw and barrel wear because there wasn't anything on the market. So we had to figure that out. And, you know, demonstrating world-class predictive maintenance solutions. That this is a really kind of showcase for that, and it is really exciting. So if you didn't know already, 23% of the world's energy is wasted through tribological contact. So if you learn nothing else today, what is tribology? It's the study of wear, friction, and lubrication. So Paul mentioned about friction, and that was one of the biggest challenges in their machine. And we're experts in measuring that. We've got a lot of experience in actually being able to tell, you know, what kind of friction is there, not only with kind of soft and lubricating and fluid parts, which we can see polymers is a fluid, but we do it in like corrosion and surfaces rubbing together as well. So that's kind of our raison d'etre and why our company's here. So, you know, that's a massive big number, 23% of the world's energy. So we've got a solution, ultrasonic sensing technologies, that can measure changes in a component or system to address these issues. So that opens a whole world of possibilities. It can drive digital transformation, industrial Internet of Things, obviously feed into the predictive maintenance piece. It can generate new data streams, when therefore you can actually start to look at maybe generating new data streams, data revenue streams as well. And of course, all of this is the whole kind of big picture of this is about reducing energy and improving sustainability. So what does our company do? We really look at connecting the digital and the physical world. And the only way that you can do that is through sensing technology. You know, as humans, we've got kind of our different senses, you know, our kind of ears, our nose, taste. So we need to do that in the industrial world as well. And how can we do that? And we do that through the sensing technologies. So Paul mentioned ultrasound. It's similar to the technology that they use to look at babies in the womb. And I've got a very short video to show how this works. So basically, we've got a transducer up the top here. And in Engel's case, we put this outside the machine so the machine can keep running. It doesn't affect the process. And we send a wave, a physical wave, into a physical system. And that wave can detect changes in that system. So this line here is a lubricant film in this case, which is half the thickness of a human hair. And it can actually detect what that size of that lubricant film is. So that kind of, as you can see, really interesting technology, and we can apply it to very many different kind of applications and systems. So this technology, as I said, opens up possibilities, and it can actually start to look at making your equipment smart. If we can do that, we can start to get data, we can start to make improvements, we can input that into the design, sort of early stage design, we can look at making savings, and we can look at predictive maintenance as well. So in this particular case, we do work across different industries. Manufacturing is a big industry that we work in, and we have got a lot of applications in the polymer industry. And we can look at things from, you know, raw materials through to processing, through to recycling. So really across the life cycle. And we can do that in different ways. You've seen the screw and barrel wear, do die wear, extrusion dimensioning, polymer melt properties, impurities monitoring, and waste reduction. And we've got a number of different customers, from Engel, as we saw, in terms of the machine manufacturer and how we can kind of do improvements there and help them as a technology partner, but also in the processing industry as well. So, which is really, really exciting for us. So in terms of our project with Engel, it started with a simple objective. Can we measure up and use in 20 minutes an injection molding machine screw and see if it's worn? And can we assess what that is and replace and look at if it needs replacing without disassembling the machine? Paul talked about, and Wayne, how long it takes to actually do that. I think 16 hours they mentioned. So we did that. We designed an ultrasonic high temperature transducer. That's what we had to patent because there was nothing in the market to do that. We developed an algorithm to be able to take that data. And what's really important here is that we are the measurement experts, but we're not the domain experts. So this has to be a partnership. You know, Engel really understand their machine, their system. They've been in that market for over 100 years. So we need to work with them to really find out how best we can solve that problem. So we did that, and that was cool. And you can see what some of the transducers look at here. But what I think there's a lot more broader picture here about making it happen. You know, this fed into the Inject 4.0 journey that Engel was going on. You know, they tried to look at some technology that was in the market. There wasn't anything that existed, and we developed something together. Developing a handheld tool that could actually go out into the market and test out whether that's something that the customers wanted. Through our relationship, we actually went and presented and had a stand on their bigger stand at the K show in Germany, which was really exciting. And we could show a model of how the technology would work. And then that looked at kind of retrofitting in some customers of theirs. One, of course, was Polypipe, who we actually met at the K show and went to meet in Lincoln, and then kind of joined all the dots of the different parties. So we looked at handheld tool. That's what we're doing first, test the market. We can retrofit the technology into assets that are already kind of working. And then the third stage is about looking at embedding that technology into the machine before it leaves the factory. So there's a real kind of iteration and journey there for how it's kind of developed. So as I said, market validation, starting to go out and test with the market, with customers, seeing what their actual requirements are. You know, they're really looking forward to having a continuous monitoring system because that can really add value to their business. And further development to actually embed that technology for the future and actually make smart equipment. But as I said, nothing happens in isolation. We had to do it together as part of this collaboration and ecosystem. We looked at the market need, access, and had a great team to do that. And what was really important is about learning together, the scale of how we do that, the outputs and the value. So developing a world-class predictive maintenance system, what does that mean for you? Like my CTO and founder he always says this, and it's right. There are no technical problems in the world. If you throw enough money at something, you will solve it. But there isn't kind of unlimited money that we can throw at all the different problems that we have. So you really need to find out what's the first thing that you need and focus on the value for you or your customer that you're trying to help. In our case, looking at from a manufacturer's and machine user perspective, you know, it's about uptime, reduction of waste, optimization, digitization. What's the savings that are going to be made? What's the business case and the value proposition? We can install our sensing technology across different lines, measuring different things and access new data, but we really need to define what that is and where is the place that's going to add the most value to you. In terms of machine manufacturers, you know, it's about performance, support, efficiencies, building up the relationship and continuing that relationship with your customers. What's driving your customers? Can you provide an enhanced service? You know, we're getting into the realms of servitization now, which is, you know, something where you can actually charge in a continuous revenue situation, which really opens up a lot of possibilities. And we can look at embedding sensing technology in new machines or retrofitting on assets in the market. So everybody can access this type of technology. There's no real barriers there. So that's me. Where can you drive your transformation in your predictive maintenance application? Please put us to the test. Thank you very much for listening.
Great, thanks ever so much, Christina. Really amazing story, and it's been great following your journey, and I look forward to following the next 5 to 10 years. Okay, on to Giuseppe, if you'd like to take control of the screen.
Yes, I will share.
So I first met Giuseppe and Black Kinetics on Innovation Alley 3 years ago, and they've gone from strength to strength since then. So over to you, Giuseppe.
Yes, so that's actually a very timely introduction, because first thing first is, so we are a high-tech startup, and we have been supported by KTN in a very, very big way for 2 years in a row before the pandemic started. And that is a great thing for us, because that allowed us to build network and to show the product. And Innovation Alley is a great experience. So if anyone in the audience is asking, is it worth doing? Yes, it is worth doing. So, and synergies, as it probably is now obvious from what the speakers before me said, synergies are very, very important in the specific sector. So that is also a very good way to get those in place. So Black Kinetics, we started the company in UK in 2018 because we felt there was a need to support better the manufacturing. And I'm going to go very quickly through the slides. So by support, we mean that we realized there is an issue with how the factories were run. This was mainly, we started in Italy really, and they have the same issues that UK has, in the sense that the factories are run in the same way that they were run in the past. And we feel there is a better way to do that. So we started looking at how we can introduce technology into the process to give insights and to give details about how the factory is performing without basically being on the couch in your living room rather than even being in the factory itself. And this, of course, translates as lost money. So ultimately, the digital innovation that we are trying to push is to make sure that the factories are more reliable, they function better, they don't have huge downtime costs, and so on. To do this, we went through like a strategy of what is missing there to really get to the point where we can have a factory that is a smart factory. So first issue first is we need a piece of technology that allows us to gather data and investigate what the data is saying. And to do that, what people are doing nowadays is using the cloud. So we are using the cloud ourselves. We build a platform that allows to gather data from different pieces of machinery that we can call assets. And the data gets sent to this secure cloud platform where it gets analyzed, it gets shown on the dashboard. And we try to do this both in a way that is useful. So we try to get, we try to put the algorithms that best represent and give answers to how the assets are performing. But we're also trying to use technologies like augmented reality, virtual reality, that allow monitoring from remote more in an easier, I would almost say more fun way. So the augmented reality is great both for documentation, is great for maintenance. It allows people with, for example, with goggles to have their hands free to operate on the machines while having the hands free to operate and having the information on the goggles, for example. There is integration with the bots on mobile, so we can interact with the different assets from a smartphone, for example. And one particular important bit, of course, is the machine learning, artificial intelligence, which is a great theme nowadays. We've been basically pushing to get into deep learning and basically get to the point where we have enough data to then use and produce algorithms that really tell us what's going on in the different machines. So this is us. We all have technical background. Marco Pennelli and myself, we are more on the software side. Giuseppe Ventrella is more on the hardware side. We don't produce hardware, but because the machines are pieces of hardware, we need to interact with them. so it's always a very, it's a kind of cross skills are needed there to be able to extract information from the machines and then elaborate it on the platform. And we had a journey from 2018 that went from incorporation to landing our first customer. We built partnerships with companies that we felt they would give us useful edge. We're going to go through a demo shortly, but for example, we are partners with Mobotics. They produce cameras, IP cameras, so we can use their cameras to receive the information directly from the factories. We are in the inception program with NVIDIA, which is very useful because they produce very powerful edge devices that can also be used and integrated within the platform. We are partnered with Sigfox for the connectivity, and all these things ultimately will end up being part of the same solution, the same ecosystem, because they are all needed depending on the situation we are facing to come up with a working solution.
Giuseppe, you've got about 3-4 minutes left, and I know you wanted to show us a bit of.
Oh yes, I'm gonna quickly switch to the demo. If I managed, where do I find it? Sorry, just give me a second. I need to find the button to share. Yes, here. Can you see the dashboard? Yeah.
Yes, we can.
Yeah, okay. So the platform is multi-tenancy, and I'm gonna just spend literally 30 seconds on the basic functionalities. It allows us to have a ticketing system, which is very basic. It's what every person would expect from a platform like this. So a typical ticket would have a title, the device that requires help, in a timeline of what's been happening. It manages a warehouse, so we would have been able to see how many spare parts we have. Is multi-tenant, which means we have different users with different permissions, and so we can also have things like managers, engineers, and we can handle the situation accordingly. I'm going very quickly because what I really want to show for the predictive maintenance bit is the most interesting bit is this, which is, so first of all, as I mentioned, virtual reality. One thing we do is integrating, for example, 360 pictures that allow people to basically look around into a plant, for example, and you can see you have dots that allow you to basically interact with different parts. And if I click on a dot, then a new page opens specific to that device. Now, here again, I can see the tickets. That is, again, the easy bit. The interesting bit for predictive maintenance is this analytics tab. Now, what's happening here is we have a pipeline that is a thermal camera connected to the pointing to the device. The thermal camera is sending data to a gateway that is sending data through an MQTT to an MQTT broker that is eventually sending data to the cloud platform. So this is all happening in real time. The MQTT, we can also see the raw data coming through. So we have a timestamp, the different types of information. The image is also embedded into the MQTT message. And in the dashboard, we can see the data itself. So the thermal camera is, as I mentioned, is from Mobotics. The cross here is pointing to the hottest point in the picture, which is also what you can see here in the radiometry measure. And on top of that, we can of course build the typical graph with all the information related to the timeline. But as you can also see, we can also do things like average, we can do linear regression. This is just for the demo, very basic algorithms, but the point here is we are receiving real-time data, we are storing it, and we're running algorithms on it. So the Mobotics camera is basically a small computer. So you already receive the information that come as you see them. So you see the image, you don't need to do anything particularly complicated on it, which is great because that allows us to focus on really the smart bits that we want to focus on, which is the algorithm running on the data itself. So this is like literally the part related to the analytics. On top of that, what we also have is a QR scanner. So imagine you have a QR code. I'm gonna put it in front of my camera if people can see it. So if I use the QR scanner on the code, the computer is gonna identify which device is pointing to. If I click on Open in AR now, if this takes a bit of time to load, cool. So this is basically showing you what you would see, for example, if you were using goggles or a visor. So you have real-time data coming from the machine that you the QR code belongs to. But also what we can do is, if you point then the QR code again, as you can see, you're gonna visualize a document, or you can make video calls or anything that is related to the machine. Now, as you can see, this is now stable, because what you usually want, for example, if you are on a tablet, is you point it to the QR code. The QR code is going to show you something. You don't want to lose that information if you then move on. So that's intended. So you have to imagine someone that is in front of the machine, needs to repair it. He needs documentation. He needs real-time data coming from the machine to operate, and he still has his hands free to actually do the work on the machine itself. Nicole, how am I doing time-wise? I had to go very fast.
No, that's about it, actually.
Okay, so
no, and what a high point to finish. I mean, I can see your face on the right-hand side of my screen, but then I can see all the pictures and your face behind it. What a brilliant use of technology, and you're using, you know, technology that's there, and you're integrating, innovating a solution to help manufacturers. I think it's brilliant. And you were daring enough to do a live demonstration, so fab on you. So
live demonstrations are always fun.
Yeah,
always
no,
fun.
Brilliant. Yeah. So
yes.
If we move on to Ray Davis now from DMIW, so the Digital Manufacturing Innovation Centre in Wales, and Ray's going to tell us all about what she's getting up to at the minute.
I'm going to try, certainly. Hang on.
Awesome. Thanks.
Yep, you can hear me good. Hopefully everything's good. Okay, so well, it's always difficult to follow the shiny tech demonstration with some talking, but I'll do my best. And actually, very usefully, it leads nicely into what DMIW is all about. As has already been mentioned a couple of times in the presentation, solutions are not often on the market already. It's often that co-creation piece. It's often that trying before you buy, the testing, the prototyping, the developing is the critical part to any new investment. So that's really what we're all about. So the Digital Manufacturing Innovation Hub Wales is very much focused on that adoption and exploitation of innovative, smart manufacturing and process technologies. So our primary concern is improving business through looking at technologies, looking at how they will work in that environment, looking at how they will improve a business process or practice, how they might improve cost, how they might, reduce costs, I should say, and improve sustainability. It's very much about how can we make business better through the adoption and exploitation of technology. Our secondary role is very much that supporting the commercialization of those innovative technologies, not only just to create resilience in the industry, but to bring new solutions forward and to really sort of pioneer new technologies at the cutting edge of the manufacturing industry as much as we can, but also not forgetting those companies that have sort of older, more legacy equipment that also need to consider how they can bring themselves in line with the modern manufacturing world. So one of the primary functions is definitely about advice and support, very much about practical assistance, demonstrations where possible, and where we can, helping to source new technologies, helping to incubate new tech providers, and providing facilities for prototyping. So we're made up of a steering group of industrial leaders and engineers. Everybody that's part of DMIW is either an engineer themselves or has worked in that way. So we've got a lot of expertise to bring to the table across the automotive, steel, aerospace, and many other manufacturing arenas. We're part of the DIHnet network of over 450 digital innovation hubs across Europe. We're one of, I think, 4 in the UK in total. Our specialist skills are very much about control systems engineering, cyber physical systems, but we're part of a wider network that cover a range of different technologies and expertise. We're also part of a UK-wide collaboration of Industry 4 Smart Factories demonstrators. Through a lot of the project work that we've done, we've started to build up a really close collaboration of academic and industrial partners with their own demonstration facilities and expertise, which we can call on as part of our support to companies. So the main focus, as I mentioned, is helping companies get access to those competencies in order to digitize products and services. It might be a new tech developer that's looking for that shop window, that opportunity to start looking and co-creating with a manufacturing company. We're also an I4MS contact point, so obviously work quite closely with European programs, again, part of a larger network of hubs and industrial providers. So our opportunities for collaboration, for research, and for accessing funding through a lot of open calls and projects is also quite high. So a lot of the support that we offer is companies coming to us with a problem, with a challenge, with something they need to address, that we can then help them source funding, source the support, find solutions providers and enablers that may be able to help them address that solution and actually facilitate that working together. Because obviously we've got a lot of engineering skills in-house as well. We can provide that on-site support where needed. If there's consultancy, if it's just general advice, we can help with that. And we can act as that technology broker. So we can, through our own membership of tech providers, we can find people who have the answer. Obviously, we've picked up a few new ones today as well. Through this discussion, so it's good to know about Blackinetics and Tribosonics, because obviously they can form part of the solution for other companies where needed. Everything we do is about that business improvement through digitalization. Most of it is about de-risking technology investment. You know, it's sort of test before you invest, it's try before you buy. Quite a lot of the new solutions that are out there, initially, you know, there's a lot of hype, there's a lot of excitement about something new to the market, and quite often companies are a little bit more reluctant to jump in straight away. They might want to see how it works. They might want to come and sort of see how it works in a live environment, and they might have their own specific challenge that they need to address, which requires a little bit more thinking. So our opportunity to bring those groups of people together and engage with some of those harder to reach manufacturers with perhaps more manual processes as well. Giving the tech developers, of course, their opportunity to break into markets they wouldn't perhaps normally, and then gathering that intelligence for innovators. So we can find out through this work about market trends, innovation data, experiments and results, and use that to help other people as well. So I'm going to hand over to Gash now to talk a little bit more about where we are and where we're based and where we've come from. So I don't know, Gash, if you want to jump in.
Gash, you've got about 2 minutes. If you haven't run away already.
Are you there?
Yeah, I can.
Sorry, okay, I beg your pardon. It's, unfortunately, the mute button disappeared off. Yeah, just to sort of run through almost the specifics of the things that Ray's mentioned. Part of what we do from that innovation point of view is to have facilities for these tech companies to almost like try some of the technologies and demonstrate all of that. So from our facilities point of view, there's a purpose-built center, which has got a lot of the sort of kit and equipment in there. I think what I'll do is, because you've got the slides, I'll sort of run through just to elaborate on that network that Ray was talking about. You can see that we're sort of forming this wider capability network, and of course working with the catapults that are already part of the sort of Made Smarter network as it is. So since we're talking specifically about predictive maintenance in here, predictive maintenance is part of the whole picture that a typical manufacturing company would certainly need to go through. So what DMIW does, as Ray said, is really look at all the aspects of it. But let's focus on these manufacturing challenges, and let's specifically look at the whole point of predictive maintenance. One of the things that we know is that there's almost going to be a guarantee that things are going to break down. That's always been the case since the dawn of time. And then what we're looking to do then is to sort of think about how we can provide solutions for that. So from a failure point of view, sometimes, and I'm being a bit cynical here, there's almost like a breakdown built into systems because vendors need to resell their services. It's a bit like having a light bulb that never burns out. You're never going to have any business from people. So that's a little bit cynical, but it's also a clear business case. And what you've got to try and do is then balance that equipment life cycle. You've heard all the things that we've heard so far, trying to balance that between the costs of breakdowns versus the sort of probability of how you can amend that. So margins are tight. So every type of technology that you come across, like AI, any slight imperfections, you know, all of that makes a big difference. And this is part of what we do, is provide the platform for people to test these sorts of things out. So it's all about data gathering, but what does that mean? It's all about sort of looking at new technologies and protocols. You heard Giuseppe mention about things like MQTT. Well, what is MQTT? So from a technical point of view, everybody can say, well, you know, it's this and the other, but we need to break that down so that some of the tech providers, some of the companies that are working with us actually understand what the technology means. So we're that conduit between the end users, the technology providers, and we sort of almost give the sort of straight talk. So in other words, an MQTT broker, for example, that you heard about earlier, is simply gathering information and pushing it out to the systems that need this information. As Ray mentioned, we've got people like Control2K on site who can demonstrate some of these facilities as well. So, you know, as well as having external companies coming in, we've also got some of the skills in-house. But specifically coming back to the challenges, one of the typical things and the big change is that everything used to be human-centered. Everybody used to gather information, fill in sheets and so on. And that's always been the notorious sort of hotspot. So it's this consistent error reporting, which has been the problem. So all these new systems that you see demonstrated and showcased, it's still all about the same things. It's all about getting the right parameters, getting the right information. You saw how, you know, between Tribosonics and everybody else, they've pinpointed those areas of concern. And from my side of it, like I said, from the DMIW point of view, is to sort of see this in context, that predictive maintenance alone is a useful tool, but you need to combine it with lots of other Industry 4 tools. You've seen these other seminars that have been organized by KTN, but it's certainly one of those areas that really makes a big difference. So from our side of it, like we said, what we're looking to do is almost demystify technologies, showcase some of these technologies, and really sort of trying to bring solutions to the end users. So hopefully, Nicole, that's as brief as I could be.
No, smashing. No, that's perfect, Gash. Thank you so much. Right on time.
Okay, great.
Anita, can you take back over the? Yeah, awesome. So into the questions then straight away. But thank you so much to all of our presenters. Again, you know, for your honesty and enthusiasm for the subject. So we've got this question here. So I guess this is for Christina and for Paul and Wayne. What needed to happen or change internally, i.e. attitudes, processes, norms, within both Engel and Tribosonics to facilitate the strategic partnership? Christina, do you want to go first?
Yes, can you hear me?
Yep.
Okay. So, I mean, Engel are a leading player. So I could say this because we're working with them, and I'm not Engel, but they're a leading player in their market. They're pushing boundaries. They lead in research. They're doing things that other kind of injection molding and other polymer machine manufacturers aren't even thinking about yet. So that's kind of one thing. And we get this a lot when we talk to different companies. You can always get a sense of where they are and where their vision is and where they are in the journey. You know, Engel had this big vision of where they wanted to go. And we started small with that, you know, first challenge, and then we moved that forward. In terms of Tribosonics, you know, we take on a lot of projects where we don't know what the solution is yet. We've got some core technology that we've invested in and developed up to a certain point, but then we have to apply that to different domains, but we don't know how that's going to be applied. So because we've got that kind of culture and the way that our teams work, we're not frightened of kind of taking projects on where we don't know all the answers. We might develop, in some projects we're doing, we might develop 5 prototypes for a particular system. So having that kind of mindset and way of working, you know, that's all from kind of our apprentices that we call our future leaders, right up into the directors in the business. Right. So that's what I would say to that.
Okay, Paul, what would your response be? What was the drive from Engel to allow you to kind of do this experimentation?
Yeah, so as Christina mentioned, it was basically, our vision of providing these solutions and the pain that we saw at the customer's end with maintaining the screw and checking its condition. And of course, we realized very early on that ultrasonic technology, like the idea that we had in mind that this technology could solve this issue or it can enable this service, is not a core competence of Engel. So we did not want to build our own sensor for something. We needed a strong partner who had the know-how. And so at first, when we realized, okay, there's nothing on the market, we needed to find a strategic partner. Where we could really openly discuss the ideas, our business plans, our targets, also to define how much we can basically invest into developing it before we go into the market, right? So also it's about a return on invest at some point, of course, directly with the service, but also in terms of loyalty and binding to provide a USP for Engel and make the position.
So you had senior management buy-in and backup for your kind of permission to invest time and energy in this development. I did put a question in myself for Christina. I was like, what's so sad is, why did it take you going to Germany to meet Polypipe? So a company from Sheffield meeting a company from Polypipe is Lincoln. Why did it take going to Germany, and how could we get better than that in UK?
I think it's just it's one of those things. We were developing it, so we're still in the stages. It hadn't been launched. You know, really the K show is where they started to launch that technology. So you know, it hadn't been exposed across their network. Engel are a global company of machines in lots of different countries. So having a demonstrator, you could see the light bulb moments, and Engel actually built that demonstrator for us. So that was moving at the K show, and it was such a fantastic. People need to see something. They need to see how it works. They need to see what the data is. So that was a while ago. I think it was 2019. We kept in contact. Obviously, they've got Engel machines. They've got other polymer machines for their products as well. But kind of having that conversation and then linking up with Wayne, who I hadn't met before in the UK, really just kind of opened up that relationship. And looking now, how do we commercialize this? How do we get this into the market and get things moving? And because obviously our technical team are here, we can support that a lot easier with COVID, because usually we travel around the world as well. It's kind of worked out really well, so we can get a lot of traction going now in the UK. Kind of
I think, a good point you just said then is about, you've got to see it, you've got to touch it, you've got to feel it, especially for manufacturers and engineers, until you actually really see it. And that's a really super link into one of the initiatives in the Made Smarter innovation program is around innovation hubs and test beds and living labs. So keep your eyes on madesmarter.uk for more information about how people can access that and funding to make those tests and to make the reality visible. So I have another question for you, Christina. How do you get your sensor data into the ERP system? Are your sensors 5G enabled?
Yes, I had to defer to my technical team to just kind of check with that. So we can provide an interface to the ERP system if you've got one yourself, because we work with global businesses. They usually have got platforms, not always, or we can work with a third party to automate that.
Cool.
And yes, it can be 5G enabled, but you need to focus on what's the right kind of communication technology for your application. So that's the kind of question that you need to answer first before doing that. And then there's a whole list of things which I don't know what they mean, but maybe lots of people do. So we can provide any interface: RS-232, CAN, USB, Ethernet, Wi-Fi, LTE. No, I need to Google.
Okay, that's great, because there was another question further down, and I was going to open it up to Giuseppe and to Gash around, is there any preference for the networks that these smart machines connect to? But I think Christina, you've probably said it all. It can do whatever you want. You just got to.
I think so usually the answer is the fastest available is always the one. The issue sometimes is that the fastest is 0G, because if you want to monitor a gas pipeline in the desert, then you don't have fast network anyway. So it really depends on the circumstances. but the fastest is usually.
And it's also about legacy systems. Like I said, manufacturing and connections have been around forever. The fact that we never called them network systems back in the 50s and the 60s doesn't mean that networks didn't exist, but the linking of the technology from the IT sectors onto the shop floor systems then started to push this battle. And the reason I talk about NQTT, and the reason I asked Giuseppe right at the beginning, you're always looking for the new ways to push this data. We're talking about cloud services. So how do you get that data from old machinery, new kit, out to these sorts of services? So 5G, the technologies are there, but people need to understand what they are, how they work, and hence the reason for having these demonstration centers to showcase this stuff.
Right. So another question here from Paul Hilford. It's good to see embedded sensors are on the roadmap. Given that machine manufacturers derive only part of their revenue from the machine sale, an ongoing majority of revenue comes from parts and labour, servicing and repairs, over the operational phase of the asset life cycle, how does Engel balance this potential loss of revenue with the desire of the machine owner operator to minimise ownership costs and maximise equipment availability and performance? So, Paul?
Yeah, it's a pretty long question, and I hope I got this got the message right that Paul Hilford wants to hear. So on the one hand, of course, when we want to basically push predictive maintenance, you could also say, okay, just put bad components into the machine; they will break all the time. So customers will ask for predictive maintenance, and then we get revenue from there. However, that's not our strategy. Of course, we always need to be at the leading edge. With our systems, with our machines. So the components that we integrate, they have to be of high quality and have to basically run for a long time, as long as possible. Injection molding machines are used for various applications, as you saw. So depending on the customer's situation, there is wear going on. We can't avoid this, no matter how good the components are that we build into these machines. And so to avoid these downtimes that are inevitable, this is the reason why we develop these predictive maintenance services. They are not tailored, they are not made for basically the whole market, because there is situations where let's say the amortization is not that beneficial as in others. For instance, if the customer has Plan B machines, if he produces on stock and has a lot of buffer, then perhaps a downtime of a few hours does not matter to him. On the other hand, there are also applications that run 24/7, and where every minute costs the customer revenue and also margin, and it leads to losses or even contractual fees. So it also depends on the customer situation. And of course, our target is to build solutions where we can clearly calculate the benefit, like with the screw measurement, where currently the customer already has a pain, he has a cost when he checks the screw. So there's an obvious benefit if you can spare, like I said, 15 hours of downtime and have boost the productivity by such a service.
Great answer, Paul. Thanks. Wayne,
may I?
Go on.
Yeah. May I jump in? I mean, the thing is, at the moment, we have to be honest and say we are really dealing with the legacy machinery that's already in the field, and to take the screw measurement, we have to perform a secondary operation to mount the sensor. And that is why at the moment it's being offered as an add-on to routine service or as a one-off measurement. Yeah. And the data then gets transferred into our system and it shows in the customer portal as a measurement, as a figure. But of course, going forward, the technology will for sure be embedded in the machine from new, and the measurement of continual measurement will be visible either in the machine HMI or be transmitted via edge device into the customer portal so he can see the continual measurement. But at the moment, we're dealing with legacy equipment where it's offered as an add-on procedure.
Yeah. And I know myself, so in answering that question, I used to work for an OEM a machinery manufacturer, pretty much the same sort of position as you, Wayne, and anything new and exciting that the tech team were doing was another reason, another excuse to build your relationship with your customer, so you were out there straight away. Yeah. Cool. So I'll ask one more question, and then we'll get into the networking. But I can see there's lots more questions. So what I can promise you is that we'll go through those, and we'll make sure that we get answers back to anyone that's answered them, that has asked them. But the next question is from Arj, which is the BX maintenance platform considering an edge computing implementation to avoid latency issues? Giuseppe.
So yeah, the answer is yes. As I mentioned, we are in the NVIDIA Inception program, and NVIDIA sells very powerful hardware for the edge side. So the solution is built in a way that we can push the logic of pretty much everything that I've shown during the demo, either on the cloud or closer to the edge. And this actually connects back to the speed of the network, because sometimes in some situations you just don't have enough bandwidth to push the data and do everything in the cloud. So if the connectivity is not good enough, and the scenario that Arj depicts seems to be exactly that, then the edge computing allows you basically to push all the components on the edge. You pretty much end up with the same functionality, but it's not in the cloud. What happens then is that the data that gets stored in the edge gets pushed to the cloud when the connectivity is there. So, it's done on purpose so that you can mix and match and adapt the solution to the specific situation. Also, I haven't mentioned, but for example, we have bots so you can control basically the application from your smartphone, as I mentioned, so you can get information on your smartphone. And this kind of functionality is also useful in that scenario, because you can connect that directly on the edge. So you end up with a situation where you literally have the same functionality locally. And that is what you ultimately need if you want a solution that is flexible and adaptable to different situations.
Great, thank you so much, and sorry for cutting you off there.
No worries.
We could talk forever, I'm sure. And there's so many more questions, but this kind of ends the formal part of the webinar, the presentations from all our presenters and the Q&A. We'll next go into a informal networking part. So if you don't want to be part of the networking, then just drop out. That's absolutely fine. But thank you so much to everyone who's joined today, and I hope that you'll take something home with you and utilize it, or make contact, or make some more new connections.